Hi everyone, thanks for joining this next session starting at 10:30 Paris time. We have the pleasure now to welcome Mr. Bruno Trebuc from CGI Business Consulting. Bruno is Director Advisor R&D Digital Twin at CGI. Hello Bruno, good morning. The floor is yours.
Okay, thank you, Laurent. Hello, everyone. So we will talk about digital twin, a large subject with many ideas behind the scenes. So we will try in just a few slides to give you some ideas of what is and what we can do with the digital twin and how to approach such things. So let's dive in now directly. So first question, what is a digital twin? The first thing is to make a clear distinction between a digital mock-up and a digital twin. So typically the digital twin, which is quite similar to digital mock-up, aims to have a bunch of virtual views helping to understand the behavior of a given system. But in fact, the difference is for the digital twin, you want to have the real behavior and not the estimated one from R&D and digital mockup. And to do that, you are based on acquisition on the real data in its operational environment of the given systems. Your system, we will see what it is. It could be different kind of things. It could be a car, an aircraft, an infrastructure, electrical infrastructure, or railways infrastructures. It could be a manufacturing system, whatever you want. So this is the aim of the digital twin, based on the real data of the system that has been acquired on the field. Why do we want to do that? Because across the whole life cycle, and we will see from the beginning, just starting to build the system, we want to be able to understand, to optimize, to predict, and when it's possible, to drive in automated mode or semi-automated, the performance of the systems and all its operations. And for this, we must be, as I said, based on real data from the field, and we will have a digital twin for each physical instance of your physical system. We will see more on the next slide. So clearly, as soon as the physical system starts to be built and alive, the digital twin exists and is being fed up with its operational data. Strong foundation on the system engineering and model-based system engineering. It's absolutely critical and mandatory to be able to understand the whole bunch of data, model, objects we will have to manage. So we'll see just a few more later on this, okay? So we talk about system. In fact, we can consider three different kinds of systems. We can consider what we can call a target system. It could be an aircraft, a building. It could be a railways infrastructure, a water infrastructure, a defense system. This is what I'm calling my target system. I can have a manufacturing system, so with a full plant or a production line, and we can have, as a third system, a support system to ensure integrated logistic, maintenance, repair, and all different operation. It's a maintenance site. Of course, these three systems can interact, and for these three systems, I can have a digital twin, okay, to understand exactly how does it work. And of course, these three digital twin can exchange if needed. So in this conference, Laurent Scheck will present a use case just after my presentation at 11:30 concerning a production line and with a dedicated digital twin with some hybrid approach on that. And when I'm working in defense industry, which is what I am doing right now, I work in digital twin on satellite space industries with defense industries. And in defense industries, we are making a sort of focus with the interaction between the target system and the support system to ensure predictive maintenance of the defense system. Just another example. Okay, so typically, if we paid a little more attention of what is a digital twin, as I said at first, we've got our DMU, our digital mockup from R&D, and I'm calling that digital mockup plus plus because there is a full bunch of information from the requirement to the system architecture to the as design with the EBOM, managing engineering BOM, sorry, managing my CAD model, mechanical CAD, electrical CAD, electronic, software. I've got the as verified with all the simulation that I can imagine to assess the behavior of my system when I am in R&D, and the as plan for all the manufacturing routings, maintenance routings, and so on. So I've got here a digital mockup. As I said, as soon as I'm starting to build my product, here with two examples of two wind turbines being built with their own serial numbers. So I've got here clearly my physical system, serial number 1, serial number 2. As soon as I am assembling and testing and integrating, let's say, two subsystems, my digital twin exist. So it will be a mirror based on the manufacturing BOM here, representing exactly what has been assembled and installed in each of my two serial number wind turbines. Okay, it's a clear mirror. And of course, as I said, if I've got 10 wind turbines, I will have 10 digital twins representing the behavior in its context, in its own operational context for each wind turbine with its own operational data, with its own life, with different maintenance operation, different repair operation, with different new updates in systems, subsystems, equipment, etc. So of course, from the digital mockup, my digital twin, as you can see here, inherits from all the different simulation models. So all these different simulation models got as input the real operational data. And of course, if I am making a focus on the serial number 1, as I said here, as you can see, we've got the evolution of our different configuration as maintained configuration now, and my digital twin through the service BOM will represent all that history of operation being supported by this serial number here. So we are fully in digital twin mode here because our virtual digital twin clearly represent exactly all the story of this physical item serial number 1. Just to continue, of course, I've got some IoTs and AMPs to control and to understand the behavior of my physical wind turbine serial number 1. I can put all this data in a data lake. I can use all this data in my data lake, as I said, to feed up some physical-based data model for predictive models based on physical law. So I can hope by this way to have a better representation of my behavior with real data from the field, as I said. But what's more, we can build some data-based model purely raised up from the analysis of the operational data, building some new predictive models. And we can have a sort of hybrid approach between physical-based and data-based model. This is typically what Laurent will talk about in the next session concerning a use case. So here I've got a passive digital twin helping me to understand what is the behavior, and it's a sort of decision aid, if I might say, for people that will have to manage this wind turbine. But what's more, we can have an active digital twin, and that will use these predictive models to directly drive the subsystems and equipment of my digital twin. So I've got both approach, passive digital twin or active digital twin, or it could be a mix in between, depending of what we want to achieve. And we've got a continuous improvement in this way of all the predictive models from physical law-based that can be improved to data-based simulation model, predictive models, purely raised up from the data, as I said. In fact, from my digital twin, at the beginning, I've got my model from R&D, and which is, as I said, the digital mockup. On the right hand, I've got my physical instance of a given one. So I've got a bunch of models from the R&D, and of course, I want to have a cockpit with some onboarded simulation models that can that have to run in quasi, I would say, real time to be able to drive. So I will have some dedicated operation to make some derivation of my complex model into small and operative model with a certain rate of error that I can admit. These are my condensed predictive models that that Advanced is pretty well known for. So my simulation models that will be onboarded on my on a vehicle or in an aircraft, on whatever physical system you want, will be made of condensed predictive models, and this is key to drive my system. Just to finish very quickly, to provide some idea of what is a digital twin in our approach, because this is a question, okay, but how can I build my digital twin? I am applying a system engineering approach on my digital twin, like you can see here. My digital twin architecture is based on 5 capabilities, which is these 5 here: integration services, transverse services, system and process mastering, monitoring, visualization, and action on my physical system, and data management for data acquisition and all this kind of stuff. I've got a bunch of 40 functional blocks. Here is an example of the functional blocks being associated to a given capabilities. And I am using these 40 functional blocks, and inside each functional block, I can have some functions, and I am drawing some kind of model-based system engineering, but applied to the digital twin itself. So it allows us in our project to say, well, in my digital twin project, step by step, I will use a subset of functional blocks to incrementally improve and develop what will be my digital twin regarding to my given business I'm working on, or whatever the business could be. Okay. It has been a very short introduction to digital twin to give enough space for your question, ladies and gentlemen, if you want. So feel free, Laurent and Franz, if you got some question, I will stop on that. So feel free to get through your question, and thanks a lot for hearing me for this very short and compact introduction.
Okay, thank you, Bruno, for this presentation. By the way, my name is Laurent. I'm the moderator of this conference. I'm sorry, on the first session we had a technical issue, so we couldn't do the Q&A session. We were still having a little bit of trouble right now, so I'm going to see if we have any questions from the audience. Let me check. I don't think we have them here. Okay, yeah, we have a question. Question number 1. How do you store and manage a digital twin?
Yeah, good point. In fact, my digital twin, if I'm going just deeper in detail, it's a sort of large digital integration platform, a huge repository with some simulation models, predictive models, with some information concerning the architecture of my systems, with maybe some 3D views, some electrical views, etc., etc. So my digital twin of a given physical individual will be stored on a central server, and concerning a given usage of one system, let's say if I've got 10 vehicles, or wind turbine is the same, if I've got 10 vehicles, if I've got 5 vehicles being used for a very specific usage, I will upload in the local computer of these 5 cars a subset of the digital twin with some models and along with some dedicated predictive models dedicated to the usage I want to have for this car. So my digital twin is split between a central server and an upload onboarded computer on my system for each physical system.
Okay. Well, thank you for that answer. We still have a couple of minutes left, so I guess I can take another question. Yeah, I have another question. Can you please explain how you would organize a digital twin strategy from a project management standpoint?
Yeah, good point too. As you have understood, digital twin is a very large, broad, huge I would say, approach concerning your system. So if you get in front of it like this, clearly you won't succeed to build your digital twin. So you must have a very incremental approach, step by step, and for that we've got a specific framework in 10 steps, very organized and structures to be able to manage and masterize your digital twin definition, allowing you to navigate through these 5 capabilities and 40 functional blocks to incrementally, in a very flexible and agile way, to build your different MVPs, minimum valuable product, okay, in the aim of agile approach, allowing you to build some incremental release step by step of your digital twin. So a framework of 10 main steps, and it works perfectly well. We are doing that in the defense industries at the moment.
Okay.
Thanks so
well,
much.
thank you for the answer. I think we
You're
don't
welcome.
have any other questions. So I invite everyone to move to the next session, which will start in about 5 minutes, which will be about P7 Enterprise, a low-code platform to enable digital twins at scale. So presented by Sergey Morozov, the president of Data Advance. So thank you, everyone, and let's see each other at the next session.
Thank you so much, and thanks for inviting me. Bye-bye.
Thank you.